I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will see the understanding conditional dependencies with the probability calculations. Let's see one by one. Understanding conditional dependencies with the probability calculation is essential because it helps in analyzing how occurrence of one event influences the probability of another. This knowledge is crucial or important in fields like machine learning, data analysis, and decision making, where identifying relationship between variables improves prediction accuracy. Conditional probability, mainly if you are taking the conditional probability models, real world situations where outcomes are independent, enabling better risk assessment, troubleshooting, and optimization of complex systems. Mastering these concepts, the dependency concepts, allows for designing more effective algorithms, improving diagnostic systems, and enhancing decision making process in uncertain environments. And we are going to see how we are going to derive the formula for B of B. That is using the total law of total probability with some examples that we'll see. And you know that here also we are going to use the base networks or base theory. Before that, we are going to find out the law of total probability. We are going to find out the total probability. The law of total probability states that if an event B, there may be any event, we are taking event B, can occur by two or more mutually exclusive and exhaustive. This is very, very important. Exclusive and exhaustive search. What is happening? This we have to analyze. Exhaustive, exclusive, and exhaustive conditions. The probability of B is the, if it has been happened by both inclusive, exclusive, and exhaustive, the probability of B is the sum of the probabilities of B under each condition. Under each condition. So in this case, A and A bar, if I am taking, are mutually exclusive and exhaustive. Either A happens or it does not happen. Does not happen means A bar. We are representing it as A bar. Otherwise, the A bar is given by minus this symbol with it. That is known as A bar. And if you are using the conditional probability from the definition of conditional probability, what it says, probability of B intersection A is equal to what? Probability of B given A into probability of A. This we have seen it in the previous slides. Conditional probability. And probability of B given here A, here A bar. A bar means what it should come here? B, instead of B given A, here it will come B given A bar into probability of A bar. So the total probability is what? Total probability is being written it as probability of B is equal to, if you are summing of probability of B given, that is B intersection A plus probability of B intersection A bar. We have included both A and A bar, exclusive and exhaustive. So this we are calling it as total probability by using. And if you are using some substitutions in the formula, probability of B, you know that by substituting these conditions, probability of B given A into probability of B A plus probability of B given A bar plus into probability of A bar. This formula accounts for all possible ways of B can occur. And why this formula works? What is the necessity of using this formula? Probability of B given A accounts for the probability of B occurring when A happens. And this is for A happens. This is probability of A given A bar. Probability of B given A bar is when A does not happen. A means happens, A bar means does not happen. Since either A or A bar must happen, both either this or that, summing these contributions gives the total probability of B. So example, if you are taking A is one event, it rains. Probability of A is, the probability of rainy is 30, that is 0.3, 30%. Probability of ground being wet is probability of B given A. B given A is 0.9. Probability of B is equal to, what is the probability of B? 0.9 into 0.3 is equal to 0.27. And A bar, it does not rain. Rain means 0.7. Does not rain means 1 minus 0.3 is equal to 1. This how we are getting 1 minus 0.3 is equal to 0.7. Probability of A bar also we can find out from this formula. It is not necessary to go for some other formula. So 1 minus 0.9 is equal to 0.1. And here 1, if you are multiplying 1 into not happens, 0.1 into 0.7, you are getting 0.07. So the total probability, if you want to find out what, here we got 0.27 we are adding, and 0.07 is equal to 0.34. And so in this case, the total probability is 0.034. Okay. So the final formula, how we are going to write, probability of B is equal to probability of B given A into probability of A plus probability of B given A bar into probability of A bar. So it accounts for all possible outcomes that can lead to B. So one example we'll take conditional probability table, CPT. We are calling CPT means what? Conditional probability. We are calling conditional probability table as CPT, conditional probability table. So we are going to take one case study. Here the probability of A is equal to prior probability of cold A, and the probability of A value we are given it as 0.1. So 1 minus 0.1 is equal to what? 0.9 we are getting. Sometimes will be given. Probability of B given A bar is probably if the person is affected with cold, probability of fever B given cold, probability of B given A is equal to 0.8. So A bar is equal to what? 0.2. 1 minus 0.8 is equal to 0.2. Similarly, probability of C given A, probability of sore throat C given cold, probability of C given A is equal to 0.7. A bar is equal to what? 1 minus 0.7 is equal to 0.3. Similarly, another condition is another event. Probability of D given B, comma C. Two events we are taking. We have taken two events. So in this case, BC, the probability of D given BC is equal to probability of positive test. D is the positive test. Probability of D given B, comma C is equal to 0.9. Probability of B bar, comma D given B bar C bar is 1 minus 0.9 is equal to 0.1. So now problem one is given by using the Bayes theorem. Given probability of A is 0.1, A bar is 0.9, B given A is 0.8, B given A bar is 0.2. What is find out probability of A given B by using the total probability. So probability of A given B is equal to probability of B given A into probability of A divided by probability of B divided by probability of B. So you are going to substitute probability of B given A into probability of A plus what we can write over here, probability of B is equal to, for this value we have to use the total probability value. We have to find out total probability value. So this we have seen it already. Probability of B is equal to what? Probability of B given A into probability of A plus probability of B given A bar into probability of A bar. So that we are writing over here A bar. Here probability of A bar. So for all those things we are having the value. Probability of B given A is equal to 0.8. Probability of A is 0.1. Similarly 0.2 is probability of and probability of A bar is equal to 0.9. So if you are adding and multiplying and adding, we are getting 0.26. So probability of A given B. What is the formula? Probability of B given A. Here the 0.8 into probability of what is the formula? Probability of A 0.1 divided by 0.26 is equal to, we are getting 0.3077. Very simple formula. And this is by using Bayes theorem, basic Bayes theorem, conditional probability. And if you are using the joint probability, the same problem. Probability of A is given 0.1, 0.8, C given A, and find the joint probability of, generally they'll give probability of A, B, C. So the formula for this is joint probability means what? Probability of A. First we have to write. Then probability of this one. B given A. Multiplied by what? Probability of A into multiplied by what? Probability of C given A. You have to write like this. Then, so you have to substitute probability of A is equal to 0.1, B given A is equal to 0.8, and probability of C given A is equal to 0.056. That is if 0.7. If you are multiplying all those values, you are getting 0.056. Here you should remember one thing. If you are given ABC, probability of A multiplied by probability of B given A multiplied by probability of C given A. One by one, all the variables it has to, if n variables are there, n numbers it has to go. This value is 0.056. And the third problem, by using the same case, probability of positive test. Here, what is the question given? D. D is given. D is the, here in the question you can see this D is the probability of positive test. So that is the third problem. Probability of B given A is given and C given A is given. D given BC is 0.03. Find probability of D given positive with the probability of A. So how you will write probability of D given A is equal to all the values you have to consider. So here in this case, so how when it will be positive, by considering all these values. So you have to combine all these values. You have to write probability of D given BC, probability of D is equal to D given either B or C into probability of B given A into probability of C given A. So if you are substituting all the values, probability of D given A, this is the probability of positive test. So positive test means you have to consider B, C, A also. So you are getting 0.504. Hope this problem, everyone understood this problem, right? So coming into the conclusion that what it says, the Bayesian network, this network provides a structured approach to probabilistic reasoning. How means Bayesian networks are graphical models that represent a set of variables and other conditional dependencies that we are going to see the DAC algorithms and all. So here the probabilities are updated using the Bayes theorem, and it is widely used in the AI applications. This I have seen it many times. Bayesian networks plays an important role in AI applications, enabling systems to make informed decisions in uncertain environments. They are used in medical diagnosis, fraud detection, robotics, and natural language processing, where uncertainties must be managed. Uncertainties must be managed effectively by modeling cause and effect. This we are by using this cause and effect method, we are going to solve some problem. Cause and effect relationship and updating beliefs with new data. Bayesian networks empower AI system to handle ambiguity, adopt to changes, main application, and improve decision accuracy over time. So hope you understood the basic concepts of how to find out the total probability by using the events A, B, C we have considered, and this in this case study we have taken the four examples. The four examples are the probability of cold, probability of fever, probability of sore of throat, and the probability of positive set. So each and the everything based on the questions we have solved the problem and found out the answer. So then we have seen the conclusion. So hope you understood the basic concepts of this probabilities and how to find out the total probability theorem. So the remaining things we'll discuss in the next class.